Hello guys, how are you? I hope all of you are doing great. So we are starting this course which is named as Theory of Computation, and in this course you'll be studying why computation is required and what is the theory behind computation. We are going to create various computation models, and uh, and we are going to explore this course to a various levels from basic level to the advanced level. It will definitely help you in your higher studies as well as your national level gate examination as well. So we are going to start with why we are studying this course, what is the importance of it, and different types of automatas that we'll be discussing in the first lecture. So we shall start by sharing the screen. Let me share my screen. Right. Importance of the course. So I'll just take a basic example. As you might have studied about C language, C++ language. When I talk about the C language and C++ language, understand what will be the important aspects of programming. When I talk about programming means I must understand this fact that there are many strings which are recognized by C as well as C++. Like for an example, declare a variable int followed by a semicolon. You do it in both C and C++, Java for that matter as well. So it means those languages recognize a string which is known as integer. It means by default it is defined. So that is why it is known as predefined data type, right? So it means this is definitely recognizable by that particular language, which is known as either C or C++ for that matter. We declare a variable using float. We declare a variable using character, right? So we declare the variables accordingly. Now the important thing is that these variables are declared, but how does the compiler know that these variables are correct? Because these variables, whether it is float, whether it is character, all are clearly defined under these languages. It means these are defined variables. It means their compilation is clear by the compiler. They know that these variables can be declared, but the declaration has to be done by data type space and variable name, followed by obviously semicolon. So this is the basic part of it. Why I'm putting stress on this particular part? Because the course that we are going to study will basically find out how this computation is done, and we are going to create the model of the same. It means I write int followed by a semicolon, right? So I have written int followed by, so I have clearly given a space between them. If I don't give a space, compiler will find out you have written int followed by a becomes int a semicolon, and unfortunately this is something which will lead to compilation error. Why? Because compiler does not know what inta is. Definitely compiler will recognize this variable, but it won't recognize this. This will lead to compilation error. So this is something which is defined by the person who has created it, and defined, and we are using it to very good effect to create various different data types. Now what does a finite automata means? Now I'm coming to this particular topic which is known as finite automata. What does that mean? I have clearly written int followed by a semicolon. Now, this I have written fine, that is totally fine. But there is a theory behind it. It means this is known as your computation. And what is the theory behind it? We don't know. We have to see what kind of theory that is applicable here and how this theory is evolved. We have to see. Now, I'm going to create a computation model of it. Computation model means that's what my automata is actually. The computation model says that firstly compiler recognize I, firstly the compiler will recognize I, then compiler will recognize N, then T, then space, then A, then semicolon. Means compiler must firstly find out whether int is used properly, then space is given, then variable is declared, then semicolon is used. So these are all the important parts of it. So how does compiler recognize it? Because there is a theory behind recognizing it also. So that theory model I am going to make, which is known as automata. Like I create a state. This is initial state. Initially compiler recognize I, right? Then another state is created. Then compiler recognizes this N. Then another state is created. Then compiler recognizes this T. Then the compiler recognizes this space. Then compiler recognizes this particular A, and then compiler recognizes this semicolon, and after everything is done, I'm returning to the final state. So over here, this is whole a compilation process. This compilation process is designed in the form of automata. This is known as the theory behind this computation. The theory is represented in the form of a model. This is actually a model, and the theory behind this is designed. And yes, it is something which we have prepared on our own from this particular integer, then space, then a, then semicolon. There is one computation done, means that declaration of a was done. The declaration of this particular a is actually possible only if we basically execute this particular stuff. So we have declared this A, and we have basically created a model behind this theory, which is known as automata. Guys, I have written a word which is known as finite automata. Why it is known as finite? Because we are using finite steps. Finite steps means I'm using I, then N, then T, then space, then A, then semicolon. So it means finite steps we are doing. We're not running with the steps like I'm using I, then T, then A. It is not done like that. It is finite steps, and I have designed the theory on the basis of that. This is known as automata. This is known as finite automata, right? So this is a theory behind computation. Any kind of computation you want to take. The computation that I took was the example of declaration of A. So that theory is designed with the help of model, which is known as automata. Since it is known as finite automata, why? Because we are using finite steps to create it. Hopefully this theory behind computation is clear. So in this course you will be designing various automatas. You will be given various scenarios, and those scenarios are designed with the help of automatas. Again, these are theory behind computation, right? So this is the very first lecture where you will be studying about finite automata. Now see, if I have talked about finite automata, so the finite automata has various types. Actually, there are two types of it. One is known as DFA, which is known as deterministic finite automata. and second is known as NFA, or in some terminologies or in some books, it is known as DFA also. So why? What is the logic behind writing those? These are two different terminologies. Since you use the word deterministic, deterministic means everything is determined properly. It means everything is defined properly. Defined properly means that there is no confusion at all. If I'm giving one input to a particular state, it will go to a particular state. There will be no confusion. But I'm talking about NFA or non-deterministic finite automata. There is a chance of confusion which can happen. So I was using the words states, input symbols. So what these are? Like for an example, you have created that integer model. You have written q1 and you have written n, then you have written q2, then you have written t, then q3, then space, then obviously q4, then obviously you have written a q5 and semicolon q6. So this is an integer model. This is why it is an integer model. Why? Because over here you have defined these integer steps properly. So you have used various states to create it. The states that you have used are q1, q2, q3, and what are the inputs you have given? Obviously, q0, when you have given input I, you are going to q1. Q1 you given n, you go to q2. Similarly, q4 you give a, you go to q5. Q5 you give semicolon, you go to q6. So these are all states. So that's what the representation of automata is. So if I'm talking about the symbols, there are symbols of NF and DF. I'm using combined, and then I'll differentiate them. The first important symbol that you have to understand is Q. Q is known as set of states. So whatever the set of states you have used, like you have used Q0, Q1, Q2 till Q6. So all are known as set of states. Hopefully this is clear. Second, we use this symbol, sigma, and whatever terminologies you want to give it to, you can. So what is this symbol? This is known as set of input symbols. So what is set of input symbols means? Whatever input symbols you have used I, then n, then t, then you have used space, then you have used a, then you have used semicolon. So these all are input symbols. So third symbol, which is in use as this symbol delta, this is known as transition symbol. So what is transition? Transition means you give any input, any state, any input, you go to a particular state. Like for an example, Q0, you have given I, you have gone to Q1. So there is a transition you have done. It means all set of states given all set of input symbols, you go to any particular state that belongs to all set of states. So this is known as transition. So it means we are changing. We are changing. Obviously, Q5 we've given semicolon, we go to Q6. So we are changing. So the fourth important symbol is initial state. You start, you go to any particular state, initial state. Initial state means I'm going to start. So obviously I have start from Q0. So that is my fourth symbol. And the last, not the least, is capital F. Capital F means, actually it means set of final states. Set of final states means you can have many final states. It's not that you will have a single final state, but over here there is single final state which is known as Q6. So this is what your model is looking like. Hopefully this is clear. These are all symbols. Now I was talking about types So let me write those. One is DFA, one is NFA. The first difference between them is it is known as deterministic finite automata. The terminology difference, and this is known as non-deterministic finite automata. First thing in this particular thing you have to understand is over here, when any state given any input symbol, only one output state can happen. Means if I give q naught a, I can only get q1. One output state I should. If I give q naught b, I can get either q1, but I won't get two different answers. Means there is no confusion, right? So in NFA, this is not the case. In NFA, the case is if I give q naught a, I might get q1, I might get q2. I don't know what is the right answer. Confusion. Means if you draw an automata, you give a, you may go to q1, you may go to q2. So I don't know which is the right answer. So for that to happen, I don't know. If I don't know, it means clearly this is a case of confusion. Anything can happen. So that is the difference between DFA and NFA, apart from certain terminologies. So let me write their transition symbols in this way, that any state given any input symbol, any sort of input symbols, it can give to set, it can go to set of states, but it won't give two different answers. But there, this is the difference between NFA and DFA. Any state given any sort of input symbols, it can go to two different answers. So I'm writing it as 2 raised to power cube. So this is the basic difference between them. That transition symbol, everything is same. Initial set of states, in all the tuples, like initial state, then input symbols, then obviously transition symbol. So that is the difference I have written. But we have again initial state as well as set of final states, and all the set of states that we have got. But the important thing to understand over here, guys, is the fact of, it's a very important fact of this part, that over here any state given any input symbol, it can go to one state, only one output is formed. But over here more than one output can be formed, right? So this is one important difference. And importantly, the diagram that we drew of this one, is it NFA or DFA? It is actually the case of NFA. Although I'm not going to two different states by giving I, but this is something which is incomplete. Let me tell you the fact behind it. Yeah. So what is the thing? In DFA, there is one condition that you have to do. One important, every input has one output. This is one important thing. And every input must have transition with all input symbols. Let's say you have two input symbols, which is I and N. So if I start Q naught, when it is given I, it can go to anything, Q1, but only one answer can be formed. But over here, clearly that N is also another input symbol. So I have written every input must have transition with all input symbols. So there are two input symbols, I and N. So Q naught will also have transition with N. But again, let me tell you that this is a basic terminology of DFA, that if you are using, let's say if you have used INT, then space, then A, then semicolon, then it means Q naught will have transition with all of them. But unfortunately, in this particular part, if we see this over here, we don't have Q naught transition with NT space A semicolon. So Q naught is only having a transition with I. But in DFA, the case is it must have transition with all input symbols, like I have explained here. But so what is NFA in that particular say? So I'm taking this example, I comma N. So in NFA, there is this possibility. It's not that always it will be, but there is this possibility that Q naught, when it is given I, it can go to Q1, and when it is given I, it can go to Q2. So it means Q naught, when it is given I, it can go to Q1 comma Q2. I don't know what is right. This is one important fact. Same applies with Q1, when it is given N, it can go to Q3, it can go to Q4. And there is no such condition that every state should have in a transition with all input symbols. This can be this can be a case of NFA only. Over here, I have not done any transition with I and N. So this is the difference between NFA and DFA. So the tuple terminology of those would be capital Q. Capital Q says you have used set of states. Then whatever set of input symbols you have, you can take one, you can take INT, whatever the language uses. Then there is transition, which is a difference. Then there is initial state, and then there is set of final states. You will study what are set of final states when we do various examples, right? And this is Q naught, this is initial state, which is always going to be same. So initial state. And what is the difference between them? The difference is that DFA, my transitions looks like any state given any input symbols, it can go to any particular state. This is one. And for NFA, this is not the case. NFA, that any state given any input symbol, it can go to two answers as well. So this is the case of NFA. So this is the difference between DF and NFA. In the next lecture, you will study all the construction of DFAs, and again when the construction of DFA goes, the important part of that is every input has one output you will study, and every input has transition with all input symbols. If you have 0 and 1, so Q naught will have transition with 0 and 1 both. But it doesn't mean that Q naught, when it is given 0, it can go to two different states. It cannot, because every state has only one output that is determined properly. So I have given you the basic terminology of this particular part. Uh, Let me basic terminology. So let me give you a real life example. Guys, I'm going to give you a real life example of NFA only. Why? Because DFA don't exist. There is no perfection. We try to achieve perfection by creating various programs or various computations, but unfortunately DFA is something which is deterministic, and everything is determined properly. In systems they don't work like that. Like for an example, you have ATM machine, right? You take an example of ATM machine, right? What does happen in ATM machine? You are a user, you insert card to a machine. Now insert card to a machine. Does that ensure always money will come out? No, it is not a surety. Maybe there is transaction failure. Maybe you have some erroneous message. So if there is transition failure, maybe they don't have enough money, or you can have error message, right? You can have error message also. After doing transition, your money may be deducted, but your money is not received from ATM. So this is clear case of NFA. Why? Because this is clear case of NFA. Why? Because you have given single input and you have multiple outputs. It means there is no clarity as such which is correct. So this is a clear case of NFA. But in DFA, if you are giving single input, you must get single output. So in real life, it doesn't happen. So even your vending machine, if you take the example of vending machine for that matter, you put your request for a particular bottle. The bottle may come out, bottle may not come out. It's again, this is something, this is something which is a clear case of NFA. So single input and multiple outputs, clear case of NFA. But in DFA, single input must give single output. So again, these are the basic examples, real life examples of NFA. I have discussed DFA also. So I hope everything is clear to you. So we will be discussing construction of various DFAs. We will be taking various examples of how to construct the DFAs and how various input symbols are processed, how a single state has transition with all input symbols. So we are creating the DFA with one input symbols. Means only one input symbol will be given to us. Like we have discussed in the previous example where I and T space A semicolon were discussed. These were the input symbols. Now we have DFA to be constructed with one input symbol. One input symbol means only one input symbol will be given. So there are basic questions that can be asked, like create DFA with one input symbols, and one input symbol we have taken as 0. So create DFA that contains exactly 2 zeros. Second question can be formed like create DFA that contains at least 2 zeros. The third question can be formed like create DFA that basically contain at most 2 zeros. So we are dealing with only one input symbol, means zeros. So how do we go about it? So let's just discuss the first example, which is exactly 2 zeros. In exactly 2 zeros, what will happen is that we have initial state, right? Now initially you just create a basic automata. Basic automata means exactly 2 zeros means what are the possible answers? 0 0 only. There is no other possible answer apart from 0 0. So I would just create one state and accept 1 0. Then I will create another state, then I will accept another 0. Since from q0 to q1 1 0 is processed, from q1 to q2 2 zeros are processed, it means my answer is coming at q2, not q1, because from q0 to q1, like say from q0 to q1 only 1 0 is processed. But if I check from q0 to q2, from q0 to q1 there is 1 0, from q1 to q2 there is another 0, so it means 2 zeros are coming at q2. So it means that becomes my final or set of accepting states, so one of the accepting state. Exactly, this is a length which is definitive length. There is no infinite length as such because only two zeros are supposed to be accepted. Fine. Now the definition of DFA says every state should have transition with every input symbol. Means every state must have transition with every input symbol. So what does that means? It means Q0 must have transition with 0. Yes, it has. Q0 which is having transition with 0, it goes to Q1. Q1 also has a transition with 0. We go to Q2. But that is my final state. So what about Q2? Does Q2 have a transition? Actually, it does not have a transition. To represent the transition, although it will not be a valid one, will create a dead state. Let's say create a dead state and create a loop of 0. What do you mean by loop? Loop means any number of zeros. Any number of zeros means 0 0 also. It means any zeros means 0 0 means null zeros, then single zero, then two zeros. It can be anything. But let me tell you what is dead state. Over here, Q2 was not having any outgoing transition because Q0 was having one outgoing transition with Q1, right? So Q1 was having outgoing transition with Q2, but Q2 did not have any outgoing transition with 0. So I will put 0 over here. I will put 0 over here. That means that Q2 now has a transition with dead state, although it is not a valid transition because it is not leading up to any final answer. Our final answer is obtained at Q2 only. So even if I have put up any number of zeros on dead state, it is not making any significance. Guys, it is as equivalent to as your comments in C++. What do you mean by comment? If you you write any statement. So you write int followed by a and then you put a comment. So after any comment, is there anything which is valid in terms of execution? It is not. So same applies with this. We are just fulfilling the definition of DFA that every state must have transition with every input symbol. So the second question that we are going to do is at least two zeros. So firstly, we'll form the answers. At least 20 means minimum two zeros are there. And there is only one input symbol, which is 0, which is involved. So minimum two zeros, right? Then it can be three zeros. It can be four zeros. So the length is infinite length. So it means I don't know how many answers I'm going to form. So we have to be very careful when we are creating the automata. Let's create an automata Q0. Let's create a generalized automata at least accept two zeros. 1 0, Q1, another 0. Then it becomes Q2. So minimum two zeros are accepted. What about if we have three zeros, four zeros, five zeros? So see, over here Q0 has a transition with 0, it goes to Q1. Q1 also has a transition which goes to Q2. So Q2 also must have a transition. So there are many options it can be applied. Like for an example, Q2 when if given 0 to Q0, Q1, so it can give us various zeros, but it can give us various answers like 0 0. Firstly, Q0 goes to Q1 with 0, Q1 goes to Q2 with 0. Then from Q2 to Q1, we are going with 0 and then again coming back to Q2 because we have to go to the accepting state anyways. We have to go to accepting state. It means a minimum two zeros were accepted, then four zeros were getting accepted. Then again from Q2 to Q1 or Q1 to Q2, the same process we apply. We are actually getting even a number of zeros. But that is not a condition because we want to get three zeros also, which is not possible here. So obviously this step becomes wrong. So I won't be executing this step. There is another option that we have to go about that. I can put 0 over here. Guys, put 0. So what I will get? I will still want to get 000. 1 0, then second 0, then 3 0 over here. Then fourth 0, because if I have to continue again, I have to come back to Q2. So Q0 when it is given 0, it goes to Q1. Q1 when it is given 0, it goes to Q2. Again, Q2 when it is given 0, it goes to Q0 again. I have to continue because I must reach final state, which is accepting state. There my string will be accepted. So it means Q0 again when given 0, it goes to Q1. Q1 when given 0, it goes to Q2. So how many zeros I'm accepting? Minimum 3 zeros if I'm putting a loop from Q2 to Q0. 5 zeros actually. So 5 zeros, I want answer as 5 zeros, but I still want to accept 000, which is not accepted from this automata. So this is also wrong. So there is only one option which is left. The option that is left is that put a loop of 0 on Q2. Guys, if I put a loop, I'll get minimum 2 zeros. Then I can take 1 0 from this. I will get 3 zeros. If I don't get any zeros from this, I'll get double zero. If I get 2 zeros from this loop, I'll get 4 zeros. If I get 3 zeros from this, I'll get 5 zeros. So I'm getting accepting everything. So this is my final answer. Last, not the least, we have the question of at most 2 zeros. Guys, at most 2 zeros, how we will do this kind of question? Firstly, at most 0 means maximum 2 zeros are there. Minimum 1 0 can be there, right? Minimum 0 zeros can be there. So 0 zeros I'm representing using null. So it means Q0. Let's create a generalized automata with 2 zeros at most 2 zeros. I am going to Q2. Now they are saying that even if you don't give anything, you are still having the answer. Whenever there is any answer that comes, it means that is my final state. So without giving any zero, my final answer is coming. It means this is my one state, which is a final state. Again, my answer is coming at single zero also. Whenever single zero Q0, when it is given 0, it is going to final state. So this is also will be my final state, because 1 0 is also getting accepted. 2 zeros are getting accepted in this state. So what tuples I explained? I explained capital Q, then input symbols, then transition symbols, then initial state, and then capital F. Capital F was set of final states. Here, every state is a final state. Q0 has an outgoing transition with 0. Q1 has an outgoing transition with 0, but Q2 does not have any outgoing transition. I cannot put 0 over here. That would mean I will have many zeros that are getting accepted by my answer is definitive. There is not an infinite answer that I'm looking at. This is going to be wrong. So clearly there is only one answer, that Q2 cannot have anything from Q2, because maximum I can have only 2 zeros. Then clearly we will have a zero transition, and the significance would be it will be going to, obviously it will be going to dead state, and dead state have all the transitions with it. So this is how this question is done, at most 2 zeros with single input symbol. I hope you got the required explanation of how a single input symbol is used. So there are many scenarios you can form. So I just use the simple basic scenarios, and we'll be doing advanced scenario, the 2 input symbols or maybe 3 input symbols. Thank you.